Hey guys, so this Friday I'm going to be giving a workshop for Reactathon, and at the beginning I need to do a little presentation about what is GraphQL. So I'm going to be giving the practice demo or practice of the presentation now, so I can get used to it, and then also so you guys can see what it actually is. So yeah, without further ado, let's get started. So why GraphQL? So before we get into this, a little about me. My name is Ben Awad, and I am a computer science student at the University of Texas at Dallas. So I make YouTube videos in my free time about programming, and recently have a major focus on React and GraphQL, as those have really become my favorite technologies. And then I also work on a product called Saffron, which is an online cookbook, and it's built with React and GraphQL. So to dig into really what GraphQL is and the problems it solves, I want to take a look at REST and what's wrong with REST, or some of the things that GraphQL fixes in REST. So to help me out with this, we're going to take an example. So I want you to think about a blog. So it could be, for example, Medium, and right here we are looking at Bloomberg's profile. Now take a look at the data on the page. This could be coming from several different endpoints or APIs if you're using a regular REST server. So here I broke it up into 3 different parts they might be fetching data for. So up here in the top with the red, they might be fetching, for example, the user's profile and maybe a description of that user. And then from a different endpoint, they might be fetching the followers and how many followers they have. And then at the bottom, another endpoint they might hit for the actual posts themselves or the stories. So 3 different endpoints to get 3 different pieces of data. So the request might look something like this. So it might be broken up into 3 different parts, and the first part we'll go ahead and make a GET request to get the user. Now I want you to take a close look at this JSON response that we're getting back from the server. Notice it has address and birthday, which are not really needed to display on the screen. So it's extra data that is pretty much useless that's getting fetched, and this is what's known as overfetching. And so this is one of the problems with REST and with endpoints. Now there is ways to remedy this problem. So one of the ways is to try to specify the fields that you need. So in our last example, for example, we didn't need the birthday or the address, so we could just query the fields that we need. So notice at the end here, I add a question mark, and we could add query parameters to specify, hey, what fields do we want to select from this endpoint? But this slowly deteriorates when you have nested relationships. And what do I mean by that? Take a look at address. So this is an object itself. So maybe in address there's a city. So what if I just wanted to select the city for the user? Well, then I would only want to select the address, and then from address I'd only want to select city. So that might look something like this, and you can see as you nest more and more objects, it can get a really messy query to try to look at and also build. So this is not a great solution with that. So this might be your second request. So again, you'll see we are overfetching because we don't really need to show the comments for the post. We just are showing like an image, for example, a title and content of the post. We're not even showing the whole content, right? On the thing, it's only showing a snippet of the content. So again, fetching too much data than what you really need. And again, we hit a third endpoint as well to get our last data about the followers. Now, overfetching is one thing, but we're also underfetching. And what I mean by that is, on the first request that we made to get the user, we also didn't just want the user himself, but we wanted the posts and the followers for that user. And we didn't get all the information in the first request. That's why we had to make a second and third request like this. So that's what's known as underfetching, and that's really the second problem. Now this can be kind of solved by creating custom endpoints. So maybe, for example, we say user/id/all posts. and then we get the direct, posts or the data that we need for a screen. And then maybe you would make a route per screen, and you would basically have the exact fields and stuff that you would need for a single screen. And this actually will work pretty well for small applications. But as stuff starts to grow, and if you're at a large company with a lot of different routes, a lot of different pages used across lots of different things, the custom endpoints can just get disgusting and all over the place. So not really a good solution at all. So GraphQL solves both of these problems. So you'll no longer overfetch or underfetch, and you'll get exactly the data that you want. And that's why GraphQL is kind of a way to do both of those things, or get rid of those problems, which is really nice. So let's take a look at what it would look like with GraphQL. So to do that same query we were just looking at with the 3 requests, here's it in one query with GraphQL. So instead of making 3 round trips, we'll now only make 1 round trip. And notice here is the query that we are writing. This is GraphQL right here. And we specify the user we want. And then on the user, we specify the fields we want. So I only care about the name. I don't want to get the birthday or the address. And then same thing for posts. So I grab the posts, and then I only want to see the title for the post, maybe, right? I don't want to see the content or the comments. So you grab just what you want. And then notice also I'm able to add a filter or argument on sub containers or sub fields, right? So for my followers, I just want the last 3 in this example. And then this is the JSON data that you get back from the endpoint, and you'll notice the shape matches the shape of the GraphQL. So it makes a lot of sense going from the GraphQL query to the JSON data, because it looks very similar and you know exactly what you're getting back. So that's super nice. So next, what I kind of want to look at is, now you know why you would want to use GraphQL and the problems it solves. Let's learn a little bit more about it. So with GraphQL, you're going to be creating a schema. So here's a very basic schema for a type called person. Now with this, you actually specify the data types or the type for each field. So for example, name is a string, age is an int, and now you'll notice on the string I have a bang sign or an exclamation mark. That means it's a required field. So I have to have a name, but age could be null, for example. Now with these, when you're setting up a schema in GraphQL, these fields are the ones you want to expose, right? So for example, I wouldn't have a type user and then show the password or have a password field. These are really only the fields that you want people to be able to select. But if I wanted to, I could only select the name if I wanted to, or just select the age when I was actually querying this type. So let's take a look at another type called post, and this is how you can actually do relationships in GraphQL. So here I have a type post, and it has an author, which is of type person. So now post and person are related. And you can finish this relationship by creating, adding a field to our type person and saying posts. And you'll notice there are brackets now around post data type. This means that we want an array back. And now you'll notice how there's 2 bang signs here. So this is sometimes confuses people. What that means is I'm going to have an array of non-null posts, and then the array itself cannot be null. So this field posts cannot be null. It has to be at least an empty array, and then inside of that, all posts. You can't have any null items in the array. Okay, so you guys saw what it looked like for a query. I wanted to show you also what's called a mutation. So queries are when you're getting data, but what if you want to create or add data or update data or delete data? You'll do what's called a mutation. And so you'll have a name for the mutation. So for in this case, we're creating a person, and then the fields. And those are just like the fields that are going to be added or created maybe in the database or wherever to do this. And then you'll notice there's a selection again. So these are the fields that I want back. So I would like to know these fields after I create this person. And then here's what the JSON response looks like back. And you'll notice how we have create person object, and inside that we have a name, Bob, and age 36. Okay, very cool. So there's one last thing we haven't talked about yet, and that is subscriptions. So there are query, mutations, and subscriptions. Subscriptions are for real-time data. So what's going to happen here is I said I want a subscription for a new person. And so every time a person is created, we'll automatically get an update in our query. An update basically add every new person, we're going to get that. So on our front end, we can subscribe to new people or new to this new person. And then whenever a person is created with a mutation, the people that have subscribed are going to be updated or alerted that, and here is the new person. And this is very similar, and it uses sockets under the hood. So this is what a whole schema looks like. Now this is very bare bones and simple schema, but you can see we have our three main types: query, mutation, subscription, and then fields inside of that. So all persons would select all the people. So we have an array of people returning back, and then we have any arguments to change that in any way we might want to. And then here are our types below. And then, so what is the point or the benefits of having this schema and the types themselves? Well, first off, it's self-documenting. And what I mean by that is you know exactly what data you're getting back and what data you need to send to the server. And you also know when things get changed. So as a front-end engineer, you're looking at a GraphQL server, you know exactly what data to send and exactly what data you're getting back, which is really nice because you might have to go over and ask the backend guys, hey, how does your endpoint work, right? So it works very well if you have a split team of front-end and back-end people, because it really helps communicate between them. And then whenever you make changes in the back-end, the front-end guys know right away because their queries will automatically crash. Because in GraphQL, it confirms and makes sure all the types match up. So when you make a query on the front end, before it even gets executed, you know whether that query is able to work on the server. And then because we set up types, it's very easy in a schema, it's very easy to mock the data. So we can actually create, we take a look back at this, dummy data for person posts this whole thing automatically. And so your front end guys can build a whole front end while the back end guys are working on the back end, and don't have to wait for the back end guys to actually finish developing create person or all persons. It's just going to be automatically done and filled with dummy data. And then when the back end guys actually finish something or finish developing out the back end, they can be like, all right, we no longer need mock data, and now the real thing works. So it's really nice for that. So next, what I want to look at is how to actually architect this, or what GraphQL looks like in a server and client relationship. So right here on the left, I have maybe your phone or your laptop or desktop computer. It makes a request, and what it's going to make a request to is a GraphQL server. And in this case, it's first going to hit GraphQL, and you can get this set up with, for example, a database. And that's pretty much all you need. So a server, GraphQL, and then a database set up. And what they'll do is you'll have define your schema, and then you're going to create something called resolvers. And resolvers is how you get data for your schema or fulfill mutations and queries. So for our all persons query, we would create a resolver that would fetch all the data from our database, for example. But the cool thing about GraphQL is it doesn't just work with a regular database. It can work on your existing setup. So you might have a REST API right now, or some number of microservices, or you might need to interact with a third-party API of some sort. So GraphQL can be a central server where the client queries from, and then GraphQL's server will go ahead and query the legacy system, the microservice, or the third-party API, get all the data, send it back to the client in one place. So this works really well, really with no matter how your backend is set up. You can pretty much just put GraphQL in the middle, and it'll just help facilitate requests. And you can also combine the two together. So in this case, we have a GraphQL server, which has a database, and then we can also mix and match this with third-party APIs and any kind of microservice or legacy system. And now it doesn't really matter where the data is coming from because you resolve each field by itself. So each field in that schema that we saw, you could get one of the fields from a legacy system, another field from a third party, and the other one from the database. It doesn't matter. You have full control how each field gets its data, and that's super powerful and very nice. So that kind of gives you an idea of how GraphQL would work in your stack. And I want to just answer a few common questions people have. So the first is GraphQL a database? It might sound like a graph database, but it is not a database at all. It's a query language, and in fact GraphQL works with any database you want. You could use MongoDB, you could do PostgreSQL, MySQL, whatever you want. And if you wanted to, you could use it with a graph database yourself. And then, is GraphQL only for React or JavaScript? Again, the answer is no. You can pretty much use this with any front end you want. So Angular, Vue, or vanilla JavaScript, or pretty much anything you want, because it just needs to send a post request, right? So our server takes a post request and then does stuff. And then on the backend side, it really doesn't matter. GraphQL is just a spec. And then you can implement it in any language you want. So it's basically just a way to solve the problems and do the things that we saw. So on the back end, we could do this with Django, Ruby on Rails, Phoenix, if we have any Elixir fans, and any database, or not database, but backend language or server language you can set this up for. But I will say it definitely is the most popular for React and JavaScript for like setting up Node.js on the back end. There's definitely the most libraries and the most support for it right now. So if I was setting something up in GraphQL, I would be want to start it with JavaScript because they just have the most support right now. But other languages are catching up really quickly too. So that's it. And this wouldn't ask for any other questions, but of course you guys aren't a live audience right now. But yeah, so this is the presentation I'll be giving at the workshop. For those of you that made it to the end, let me know what you guys thought. If there's any feedback you have or anything you'd recommend changing before I give this live. So yeah, thank you guys for watching. That's it for this one.